h bar h by 2 pi into h by 2 pi, then you get this n square h square by 8m a square. You got rid of pi here. If you expand n square h square by 8m a square, energy level. E is independent of K. E is independent of K. Energy levels are discrete, indicating the electron behavior as a particle in a potential box as shown in the figure below. Okay, here you see on y-axis p sin alpha a by alpha a plus cos alpha a. On x-axis we have taken alpha a values 0 pi, 2 pi, 3 pi and so on. These are varying in between -1 and +1 because right hand side cos value is there. Cos varies from -1 to +1 and P is potential barrier strength. Okay, so for P tends to 0. Earlier case when P tends to infinity, what will happen to E? We got this. What will happen to E when P tends to 0? This potential barrier strength tends to 0. That means, you know, when it is approaching positive ion, what will happen? That is what P is 0 means. Cos alpha A is equal to cos Ka, it becomes. Okay, cos alpha A is equal to cos Ka, because the equation here in this equation, this is equal to cos Ka, right? This is left hand side, right hand side is cos Ka. If P tends to 0, this entire expression will become 0. Only cos alpha A is equal to cos Ka. Then alpha is equal to K from this equation. Alpha square is equal to K square. Alpha square is 2me by h bar square. Then E is equal to h bar square by 2m into K square. This is actually energy of a free particle. This is actually energy of a free particle. When P tends to 0, the left hand side of the equation 8 will not cross plus or minus 1 as shown in the figure. Okay. So hence all the energies are allowed to the electrons. Hence all the energies are allowed to the electrons. See, when P tends to 0, when P is 0, the left hand side of the equation will not cross plus or minus 1. Okay, as shown in the figure. Hence, all the energies are allowed to the electrons. Thus, by varying P from 0 to infinity, the energies of electrons will vary from continuous to bound. That is, free electrons to bound electrons. Okay, E versus K diagram, it represents the free electrons moving in periodic potentials of the lattice can have energy values only in the allowed regions or zones. It is possible to plot the total energies of the free electrons versus their wave number or propagation vector K as shown in the figure. So we can plot total energies of the free electrons, versus their wave number or propagation vector as shown in the figure. See, you can see 0, pi by a, 2 pi by a, K is equal to pi by a, right? N pi by a, wave vector. Okay, so forbidden, allowed, forbidden. You can, it goes like that. Allowed region and then forbidden region, allowed region and then forbidden region. It goes like that with respect to this one, E and K. We observe that the curve is not continuous. It's not continuous, right? Because allowed band and then followed by forbidden band, allowed band and then forbidden band. So alpha is actually energy, P is some angle here. Okay, V naught B is barrier strength. P tends to alpha, infinity, P tends to 0, what will happen? That is actually barrier strength. P is actually barrier strength. We have derived in between P when it varies from 0 to infinity, what will happen to electrons? Electrons will have bound to continuous states. K is actually 2 pi by lambda, wave vector. Energy of the particle now from this Kronig-Penney model, with what we derived, E is equal to h bar square K square by 2m, that is equal to P square by 2m. P is equal to mv, momentum in quantum mechanics, mass into velocity. This also can be written as P is equal to square root of 2me, which is equal to h bar K here, h bar K here. Okay. That is equal to 2me whole power half. P is equal to h bar K, crystal momentum. Okay, this is crystal momentum. Rate of change of momentum is equal to force. Rate of change of momentum is equal to force. So alpha and K are here variables, wave vector, and then A alpha 2me by h bar square. P naught by barrier strength. P is related to potential barrier strength. So what will happen to potential when it varies from 0 to infinity? We got derivations. We got curves, E versus K curves, that it is varying from continuous to bound state. We got allowed region and then forbidden region. This is about Kronig-Penney model. Kronig-Penney model is actually what it speaks about. Actually, electrons will experience periodic potentials. See, this expression, this diagram became square like rectangular squares. This Kronig-Penney, they made it like, okay, instead of curves like this. Here this became rectangular like this, and this became rectangular. This became barrier. This became well, potential well. This became barrier. This became potential well. So it is continuous, right? That's why function is in terms of x plus a, because lattice constant is a. That means any two atoms distance is a. In between these atoms, potential energy will be maximum. Okay, స్థిరత్వం ఎక్కువ ఉంటుంది atom కి, electron ki, endukante it is halfway between the two atoms. In fact, we should not say atom here, it's ion, positive ion. In between two positive ions, it is potential is maximum. When it approaches positive ion, potential energy will be very much less. V is equal to 0. Here it will be V is equal to V naught. So Kronig and Penney, they just modified these curves into rectangular squares, and then they assumed rectangular square wells and then derived the conditions. According to Schrodinger's time-independent wave equations, they try to apply for regions 1 and 2, and then they successfully explained. There are allowed regions and forbidden regions. Allowed regions and forbidden regions. That is what about E versus K diagram. Okay. So that's all about this one. We already discussed classification of crystalline solids, how they got divided into solids, got divided into conductors, semiconductors, and then insulators. So a few basic things we'll go through. According to hypothesis, when particles are accelerated, they will spread like a wave with a certain wavelength. According to de Broglie hypothesis, when particles are accelerated, then they will spread like a wave with a certain wavelength. P is equal to mv, or momentum of the photon. P is equal to mc. This is for material particle. This is for light photon. The chemical potential at 0 temperature is equal to Fermi energy. The wave function is a mathematical tool used in quantum mechanics to describe any physical system. Psi is a function of position and time. Mod psi square is actually normalized wave function is equal to the chance of finding the subject. That means chance of finding the electron or material particle at a certain time and position. So Schrodinger's time independent wave equation d square psi by dx square plus 2m by h bar square into e minus v into psi is equal to 0. This is known as two-dimensional Schrodinger's time independent wave equation, which explains the motion of a charged particle in a potential v. Motion of a charged particle in a potential v. Okay. So usually electromagnetic radiation comes out from moving charged particles and electrons or whatever. That is, matter waves are not electromagnetic waves. Okay. P is equal to E by C, lambda is equal to C by V. Momentum of the photon. These are all few basics about, quantum mechanics. We will quickly go through the rest of the topics that we are left with. Hope you all could see the PPT that I am sharing, students. If at all
Yes,
you are
ma'am.
seeing, then fine. Fine, good. Actually, from the notes, I have taught many things. We'll just go through what topics are left for this PPT. Rest everything is fine. I already told you band theory of solids. This is also called as zone theory. Classical free electron theory, Drude-Lorentz theory, I told you, it is developed in 1900. In 1928, yes, quantum electron theory, free electron theory is developed by Sommerfeld. Okay. The difference between quantum and band theory is electrons move with constant potential, they assume. Here, band theory of solids or zone theory says that electrons move in a periodic potential provided by the lattice. That's why it could explain successfully how solids got divided into three different categories. So I have shown this expression, this diagram. So forbidden, allowed region, forbidden region, allowed region, forbidden region. E versus K diagram, it is looking like this. P sin alpha A by alpha A plus cos alpha A is equal to cos Ka. Okay. This curve is actually showing the energy E as a function of K. E as a function of K. By varying the values of K, actually, we get energies, different energies. So what is effective mass of the electron? When an electron in a periodic potential is accelerated by an electric field or magnetic field, okay, when electron in a periodic potential is accelerated by an electric field or magnetic field, then the mass of the electron is called effective mass. Okay, because of this, because of the influence of electric or magnetic fields, mass of the electron is different, that is called effective mass. Then we say electron acquired effective